Good afternoon, everybody. Thank you for joining us today on Grade 10 Mathematical Literacy, Week 7. I'm happy to be joining you guys from today, and hopefully we can have a lot of fun and I can help you through MathLit. So without further ado, Mickey did introduce me on Friday when I sat in her class. So to those of you that didn't join, my name is Mike. And today we'll be carrying on with the topic of probability. So I hope everybody is ready. What we'll do is we'll go through everything that you guys did last week, just to make sure that everybody understands things. And then if there are anything you guys can just ask via the chat, just, if there's anything you don't understand, we can go through it again and just make sure that everybody is up to date and, just comfortable with the work that we're currently dealing with. So like I mentioned, what we'll do is we'll go through everything that you did last week from probability. So some of the objectives, we'll go through a quick recap of last week's lessons. And we'll also be reviewing the tree diagrams and the two-way tables that you did. And then that should be all the time, all that we will have time for. But then during the rest of the week, we will definitely be spending some time on practicing, making sure that that we get in enough practice for each one of the tree diagram and the two-way table, that we are familiar with it and comfortable using them. So let's go. And then, so what we're going to do is we're just quickly going to check what you have done last week. So we're quickly going to run through that. So you guys did interpreting situations involving probability. You also did the probability range scale, expressing probability using fractions, percentages, and decimals, predicting the outcome of certain events, determining possible outcomes. And then, like I mentioned, our main focus for the rest of the week will be using tables and diagrams to express or calculate events and outcomes. So let me quickly ask you guys, probability, who can tell me, you can just short answer in the chat section, tell me what is probability? Who can give me some explanation of what is probability? Anyone? What is probability? Can anybody give me a short description of what probability is? Okay, there we go. Musa, the possibility of something to happen. That's a great answer. Thanks, Musa. Anybody else wants to add something to that? But basically what Musa said, that is a very good description. So probability is, I see Vicky also. Vicky, thank you very much, is trying to finding something happen. Okay, to find something happen. Okay, favorable outcomes to a total number of possible outcomes. That's Megan. Like flipping a coin. Okay, yes. So probability is the measure of how likely it is that something will happen. Okay. And then also we can see it is the study of the chances of things happening in future. Great, thanks a lot, guys. So, and then I'm sure you guys recognize this. You've done that. It's the probability scale. So who can tell me, what does this represent? How do we use it? Anybody, any ideas? Obviously on the one side, let's start on the one, we have things that are impossible, what would we have on the other side of the spectrum? If something is impossible, the other side would be possible. There we go. So yes, on one side it is impossible, the other side is possible. So the probability of an event that is impossible, we represent by using a 0 or a 0%. Okay? Who can tell me what do we use to represent the possible side? On the probability scale, what do we use? So for impossible, we use 0 on the probability scale. For possible, on the other end, what would we use? We would just use a 1. There we go. So the probability of an event that is certain to happen would be 1 or 100%. Now also in the middle, we would have an even chance of either outcome happening, so either impossible or possible. And then we can break up the probability scale in smaller sections, but for the example today, we'll only use a 1 on 4 and a 3 on 4. So if we look at this, what would the percentage be of 1 on 4? Anybody? So 1 on 2, there we go. Thanks, Musa, 25%. Remember, if I ask percentage, we'll give it in a 0 to 100 percentage. What Megan mentioned, Megan, remember that would be if I ask you guys to represent it in a decimal. Okay, so, and remember, it will not just be the 0.4. With probability, it is, I'm going to quickly move past this. I just want to show you there, that last slide. What is probability? It is the number of successful outcomes over the total number of possible outcomes. Okay, so for example, you can see there, it says 1 over 4. So it's one possible outcome out of 4 different events that, or yeah, if something that would happen 4 times, only one of them would be favorable. So remember, 1 in 4 out of 100% would be 25. And then 3 out of 4, or 3 over 4, what would the percentage be for that? There we go. Thank you, Megan. 75% line art. There we go. So yes, now we're going to quickly look at the different ways. We've just mentioned some of them. The probability can be written or expressed in 3 ways. Okay. We've now already mentioned, you guys answered in percentage. So yes, probability can be represented or expressed in a percentage. What are the other 2 ways of us expressing the probability? So percentages is 1, decimals, there we go, Megan. And then the other one, I think I gave you guys a clue over there. Fractions, there we go, very nice. So we have common fractions, decimals, and percentages. Can everybody remember those? Yes, there we go. Yes, Vicky and Megan and Lionheart, you guys are very active. I like it. Thank you very much, guys. I want you guys to remember that I'm here for you, and that, you know what, the more we can just interact with each other and the more comfortable we will become with each other. I know you guys have had a different teacher now for the last week or so, and now again, you guys have a new teacher, but I really hope that, you know what, we can have a nice relationship, and that, you know, guys can feel comfortable. Just, you know, if there's something that you don't understand, you know, put up a raise your hand little icon, and we can try and figure it out together as we go through the lessons. It's really important that you guys are comfortable and that you guys really feel confident, because I know you guys, because I sat in on Friday and I just watched what you guys did. And I can really see that there was so much potential in this group. And I'm going to share with you a little bit about myself just before we carry on. I really do love teaching, and my wife and I have only been back in the country for about a year because we were teaching in Taiwan. We were there for 6.5 years. So now I've taught kids even from, I was at a kindergarten where I had kids that were 2 years old, and I had 22 of them in one class. So you can just imagine how hectic that is. And then I've had kids up to 18-year private students that I taught at their homes. So I really do have a love for teaching, and I really want you guys to feel comfortable to ask questions. There's nothing, you've probably heard the saying as well, there's nothing like a dumb question, and I really believe that. As long as we stick to the topics, and as long as it is to further yourself in what we are doing, there isn't anything like a dumb question. So I really want to encourage you guys to study hard, to pay attention, because you know what, you guys did take the time to be here, to log in, and let's use the time to really further ourselves. Okay. So probability is also denoted by the symbol P. When we use the formula, I'll go there. Probability is calculated using the formula. I showed you guys the formula a bit earlier. So who can remember, how do we calculate probability? What is the formula we use for probability? Who can remember? So it would be probability, which would be P equals, what is the formula we use to calculate probability? Remember the fraction? The fraction is two numbers, one over another. So what do those numbers represent? Who can remember? What's on top? What's on top of the line? Probability equals, let's see, I'm going to give you guys some more time. Probability equals, okay, I'm going to go on. I'm going to show you guys the number of success. There we go, Megan. Number of ways in which something can happen over the total number of possibilities. There we go. So guys, remember, so on top, we have the number of successful outcomes over the total number of possible outcomes. So remember, when we have a coin and we flip it, we can have one of two possibilities, a head or a tail. So that would be our total number of possible outcomes, 2. That would be at the bottom, okay? So if I say, how many of those out of those possibilities would give you a head? Only one of them would. So that's the number of successful outcomes, okay? So always the number of successful outcomes over the number of possible outcomes, okay? Now, here we're going to look at the probability scale in a bit more detail. Like we explained now, I'm going to ask you guys some questions about it. So first of all, here we have the coin. We have got 2 coins. We've got the first coin on the left-hand side, and then the second coin on top. Now, in this example, we can see it says, how many outcomes will deliver at least one head? Okay, there we go. Nice, Megan. It's called a two-way table. Very nice. We'll go into some more depth into two-way tables a bit later on, but nicely spotted there. So who can tell me the question we asked? It is, how many outcomes will deliver at least one head? If we look at the two-way table, like Vicky mentioned, we have, there we go. Thanks, Megan. We've got 2, 3, I think she made a bit of a mistake on the first one and then changed it. Okay, there we go. So we've got one coin can either have a head or a tail, and then coin 2 can also have either a head or a tail. Now together we can have a head-head, or we can have a head-tail, or a tail-head and a tail-tail. So let's see quickly how many outcomes will deliver at least one head. Lionheart, remember, HH is the first coin if it lands on a head, and the second coin lands on a head. Okay, so remember, I'm going to quickly, I see that you guys are, okay, let me explain quickly. We've got 2 coins, right? Let's go back to, oh God. We've got 2 coins. One coin has 2 sides, right? A head and a tail. You'll see on the left-hand side, it says first coin, head, tail. And then on top, it says second coin, head, tail. Now, if we flip 2 coins, each coin can either land on a head or on a tail. Okay, so HH is for if both coins land on head. Okay, HT is if coin 1 lands on a head and coin 2 lands on a tail. If then the next one we've got is TH, which is tail head. So coin 1 is a tail, coin 2 is a head. And then TT is if both coins land on tail. Okay, so how many possible, okay, let's quickly talk about how many possible outcomes would we have if we take 2 coins and we flip them into the air. Look at the two-way table. How many total outcomes do we have? How many total? Now remember, how many total outcomes do we have? We've got an HH, we've got an HT, we've got a TH, and a TT. So there we go. Thank you, Megan. The total number of outcomes are 4. Now the question is, how many, okay, let's quickly do this. The most important thing about any question, math, English, Afrikaans, science, is to first establish what exactly it is that they're asking of us, okay? So, yes, if you look at the screen says how many outcomes will deliver at least one head. And I see a lot of you people said 3. But remember to listen carefully to what I'm saying. It is, I asked how many total outcomes would we have? And that's a total of 4. There we go. Vicky, HH, HT, TH, and then TT. So, but now in the example, it says how many outcomes will deliver at least one head? So we have HH, yes, there are 2 heads, but it's got 1. We've got TH. It is also, we've got HT. TT, does TT have a head in it? No, it doesn't. Okay, so how many outcomes will deliver at least one head? From the table, we can see that there are 4 possible outcomes, 3 of which that will deliver at least one head. There we go, Lionheart, Megan, very good, Vicky. Three, there we go. Okay, so what I want you guys to remember our formula. Probability is the number of successful outcomes. So in this case, 3 over the total number of possible outcomes, which are 4. Okay. So in this instant, how would we express the probability in terms of a fraction? Who can give me the fraction for this current event that we are dealing with? So 3 of which that will deliver at least 1 head. So what would be the fraction for this? There we go, Vicky. Very nice, Megan. Lionheart. Very good. So yes, P equals 3 over 4, written as a fraction. Now, if we write that as a decimal, who can tell me what would be the decimal for this equation? What is 3 over 4? Remember, what is 3 over 4? It's 3 divided by 4. So if you want, you can use your calculator to work that out. And remember the scale. Look at the scale. 3 over 4. There we go. Lionheart, fastest finger. Vicky. Does everybody understand how we got to 0.75? Okay, so you can just take your calculator, put 3 divided by 3 divided by 4, and you would get, there we go. Thank you, Vicky. Yes, we divide the numbers. Okay, so be careful. Don't just put 0.3. That would 0.3 would only be if we had a scale where there would be 10 items, then it would be 0.3. So, but on this one, we only have 4. So 3 divided by 4 is 75. Okay, so 0.75 as a decimal. Now, who can tell me what do we do if we want to make it as a percentage? There we go. Lionheart is fast. He actually typed the answer before I even asked the question. Yes. So to get a percentage, what do? We times it by 100. Okay. So there are the 3 ways of us writing probability. Remember, it would be either a fraction, a decimal, or a percentage. Now, a fraction would just be, like I said, the number of successful outcomes over the total number of possible outcomes. Then a decimal, we just divide the numbers. And then to get the percentage, we just times it by 100. If you want, Vicky, if you want to get the percentage, you will times by 100, yes. But remember, like I said, if somebody asks you a question, make sure you look at what they require from you. Okay, so if they want you to write it as a fraction, leave it as 3 over 4. If they want you to write it as a decimal, then you divide it. And then if they ask you to provide the percentage, how likely it will be, then you write it as a percentage. There we go. Thank you. Okay, let's move on. Okay, now this is where we're going to spend some time today just to go through our two-way table and our tree diagram. Okay, a two-way table, let's quickly go through that just to remind ourselves what a two-way table is. I'm glad to see, Vicky, you're back on top. Very, very nice. Thank you. The two-way table is used to list the possible outcomes of a compound event. So a compound is just more than one happening at the same time. The possible outcomes from one event is listed in the top row, like we had coin number 1, and then the possible outcomes of the other event is listed in the first column that's down. That would be coin number 2. And then the table is used to calculate all the combinations of the 2 events, like we said with head, 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 tail, tail, head, and tail, tail. So here we have a different example. On top, like we said, we have all possibilities of die number 1. So we have got two dice here. We've got a white one and we've got a red one. Okay. So on top, we've got die number 1. And how many sides do a dice have? How many sides? 6, right? There we go. A 1, a 2, a 3, a 4, 5, and a 6. Okay, so those are all the possibilities for one die. So if we roll a die, we can have either 1, 2, 3, 4, 5, 6. And then down on the red die, obviously, also 6. Now, so that would be all the possibilities for die 2. Now, if we roll both of them together, there's a number of possible outcomes. Okay? Who can quickly tell me how many possible outcomes would there be if we roll 2 die at the same time? Twelve. Look carefully, guys. If you look at the two-way table, you can quickly count how many different possible combinations there can be. Remember, if you roll, there we go, Megan. If you roll die number 1 and it lands on number 1, die number 2 can either be 2, 3, 4, 5, or 6. Okay? If you look at the column there, you'll see, there we go, Vicky, very nice. Yes, if you want to know the possible outcomes, we always do the square root of. So we've got 6 possibilities, die number 1, 6 possibilities, die number 2. So we have a total of 36 possible outcomes. If you write it down on a two-way table like this, you don't even have to guess if you have the time. If it gets bigger, it's going to be a bit more difficult. But on a diagram like this, you can just quickly count the blocks. We have 1 and 1, 2 and 1, 3 and 1, 4 and 1, 5 and 1, 6 and 1. Or we can have 1 and 2, 2 and 2, 3 and 2, 4 and 2, 5 and 2, 6 and 2. Can you guys see? So we will just count all of them together and we will have 36 possible outcomes of rolling 2 dice at the same time. Does everybody understand? Okay, Lionheart's with us. He understands. Everybody else? There we go. There we go. Tira, Megan. Nkosipile, Vicky. Okay, so everybody understand now that, remember, don't just multiply it by 2 because we've got 2 die. Each die has 6 numbers. So we cannot just times by 2 say we're going to have 12 outcomes. Each die has 6 outcomes. So each of those 6 outcomes can be matched with any one of the 6 from the other die. So in total, we have 36. Okay? And then, but don't worry, we will practice this in. The rest of the week, we're really going to take some time, do some exercises. I just wanted to go through everything with you again to just make sure that you guys stay familiar with it. And then we're going to practice it in. Now, the tree diagram you guys did before the two-way table. A tree diagram is used to express the possible outcomes of single or a compound event, okay? Each branch in a tree diagram represents a possible outcome. Okay, now if we have more than 2 dice, we won't really be using the two-way table, okay? In that instance, we'll use the tree diagram. It just gives us some more space to see what happens, okay? So let's look. We've got a coin again, okay? So if we flip that coin, how many possible outcomes do we have? Let's quickly see how many possible outcomes do we have. We take one coin, flip it into the air, let it bounce on the floor. How many do we have? 0, 2, 2. There we go. Yes, we only have 2. We have a head and a tail. That's all we've got. Okay? 2 sides of that coin. Okay, so those we call, in the tree diagram, we call the branch. Now, as you can see what we said in the description, each branch in the tree diagram represents a possible outcome. Outcome 1, head. Outcome 2, tail. Okay? So 2 possible outcomes. Megan, we won't be doing that today, but later on during the week, we will look at some other outcomes, and but for now, we will just be focusing on this. Okay, so a head, a coin, we flip it, we've got a head and a tail, and we've got 2 possible outcomes. Now, 2 possible outcomes, 1/2 gives us a decimal of you can tell me, if you look on the screen, you'll see it. 1/2 gives us, what's the chances? 2 things, a head or a tail, 0.5. There we go. Decimal 0.5, percentage 50. Remember, just line hard. If the question I asked was, give me the decimal, so then it would be 0.5. There we go. No problem. Just always remember just to, I like it, you guys giving me the answers. I love it. And this is why we go through these things, that we make sure, and that's why the only reason why I'm correcting you. So you guys don't have to feel bad if I say your name and I tell you, you know what, just be careful to do that. This is where we learn and we take the time to fine tune. And then so that when the time comes that we write tests, we know exactly what to do. Yes. So we've got a 1 in 2 chance of it landing on a head, and a 1 in 2 chance it landing on a tail. So it's a 0.5 decimal or 50%. Okay, so let's quickly look at, and we're going to look at the same, we're going to look at the same tree diagram, but I've just set it up a bit differently, just so that you see that sometimes it's not that they try and trick you, it just looks different. So I want you to prepare you guys, you know what, even if they just change the direction of setting it up, that's nothing different, it's the same thing, it's now just flipped on its side. So we've got the coin. Yes, Vicky, it is also still a tree diagram. You will see now. I just swapped it or switched it around a bit, just so that you can see that, you know what, if you see something like this, don't worry, it's the same thing. So we have a coin and we toss it into the air, flip it. We have 2 outcomes. We have a head and a tail, okay? Now, if we carry on, if somebody asked you, you know what would the probability be of getting a head after 3 tosses of the coin, or flipping the coin 3 times? Now remember, so the first time we've flipped the coin in the air, we had a head and a tail. Now, if we flip the coin a second time, okay, so what would happen? That head would either have a head or a tail, right? And what would the other outcome would be? The tail would have, also it would have a head and a tail, right? Everybody understand? There we go. Thank you. Yep, there we go. So now, each one of those, if we flip the coin again, would have a head and a tail, a head and a tail, a head and a tail, a head and a tail. Okay, so now if we look at that, how many possible outcomes do we have for this event? How many possible outcomes do we have? If we go down the line, you will see the first one was head, 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 tail. Or we can have head, tail, head, head, tail, tail. Yes, there we go, Megan. You can just count them down there, 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay, now from this, you can have this is what we will deal with during the rest of the week. You will get a number of questions, okay? 8 possible outcomes. Remember, probability is the number of successful outcomes over the total number of possible outcomes. Now from here, your examiner or your teacher can ask you a number of questions. They can tell you, they can ask you, out of the possible outcomes, how many would end with a tail, okay? Or they can ask you, so there can be a whole number of questions from this specific tree diagram, but we will practice that in a bit tomorrow. Okay, now, this is what I want you guys to do. Remember what I just showed you, okay? I do have some homework for you guys. It's very easy. You'll see, I'm not asking you questions that you haven't seen before. It is just draw a tree diagram of the following event and answer the following questions, okay? So it's a very easy question. The local mall has a family day filled with fun activities and games. They have a spinning wheel with 3 colors. Okay, so there you won't have 2 outcomes like head and tail. You'll have 3 outcomes, red, blue, and green, all equal in size. Now that is important. They have to be equal in size for them to land, for the probability of them landing on each color. If the sizes aren't the same, then the fractions in that would be different. So then there would be a whole different calculation. Same calculation, but then different numbers. But we all know now the probability of it landing either on red, blue, or green is the same because they've got the same size. Okay? I want you guys to go and draw it. Don't answer now. I want you guys to draw it, and then you'll see my email is on it, or we can discuss it a bit tomorrow quickly. So don't answer now. And but I want you to look at it. So then there's a second wheel. There's a second wheel with the same colors, so also red, blue, and green. To win a prize, both wheels have to be on the same color. So if you spin the first one, it needs to be red. If you spin the second one, it needs to be red, or blue, blue, or green, green. Okay, so how many possible outcomes are there? I want you guys to do that for me. Just do the tree diagram, count them, you'll see. And then how many outcomes will win a prize? B, and then C, what is the probability of winning a prize? So you will use the answer you got in B. I know you can do it, Vicky. Don't worry, you'll see. As soon as you draw the diagram, you'll be able to just count them out. You'll see. Just do exactly what we did here. Instead of head and tail, start with blue, green, and red. So I've helped you out now, right? So if you spin a wheel, it's got 3 outcomes, not 2 outcomes. The outcomes would be blue, green, and red. Okay? Then just take the second wheel and go from there, and you'll count them out. So how many possible outcomes are there? How many outcomes will win a prize? Remember, to win a prize, both wheels need to have the same color. Doesn't matter what color, it could be red, blue, or green. And then C, you would take the answer from B and write it as a fraction, a decimal, and a percentage. Remember, we did that. 3/4 is 0.75. and 0.75 is 75%. So you write it in all three ways we can express a probability. Okay? Do you guys have any questions? Quickly, we just have a few minutes if you guys want to ask me any questions quickly. No, Vicky, sure you're okay. Anybody else? You're absolutely welcome, Vicky. Like I said, I really love teaching you guys and for the opportunity to just share with you. And I really hope I can help you guys. So, and like I mentioned, from tomorrow, for the invitation for tomorrow's lesson, as they say, practice makes perfect. Okay, and we will really focus on tree diagrams. That's why I want you guys to really go and try and do the homework I gave you, just to see, you know what, just practice, practice, practice. Then we will be able to take it from there. And tomorrow we will really go into tree diagrams. I'll ask a couple of questions. We'll take some time to make sure that everybody can do it. I'm going to show you guys the homework again, just so that everybody has it. Okay, so really go today and sit. I mean, if you go sit down, do what we did with the coin. Remember it, write it out. Write it out, count it if you have to. That's the way to do it. You know what? Don't try and guess it or just look at the questions, really see what the question asks of you. Sit down, draw it out, and then from there you'll see it just gets easier and easier the more we practice. Okay? So remember, tomorrow, practice makes perfect. We will do tree diagrams. Okay. I'm going to go back to this homework so you guys can just take a screenshot. I'm going to leave it up there to make sure that everybody has it, okay? Make a screenshot, keep it, take a picture with your phone if you've got your phone with you. And then I'm going to go back to the first screen as well. So if you really want to mail it to me, you can, but we will also just go through the question tomorrow that you guys can see. So I hope everybody's got that. Does everybody have the homework? Yes, Megan's got it. Lionheart, Vicky, there we go. There we go. Thank you very much, guys. I really appreciate it. And all the best. I know you guys can do it. You guys have been great, and you've made me feel very comfortable and relaxed. You guys are awesome. And I'm really looking forward to teaching you guys going forward. So let me just quickly go back to the first screen just so that you guys can get my email address if you want that. There we go. You are absolutely welcome, Megan. It was nice having you guys. There we go, mgeldenes81@gmail.com. Thank you very much, guys, and I'll see you tomorrow.